Hi everyone, welcome to Data and Donuts. My name is Providenza Catalano. I'm part of the planning team of Data and Donuts and also a consultant with Compiler. I'm so excited to see you all this morning. I hope you've been enjoying some coffee and donuts and getting to know some folks maybe you've never met before. I just wanted to remind you that we are live streaming and recording today, so this will be available online if you want to tell any of your buddies about all the interesting stuff you learned today. Um, Dana Donuts, we've been doing this for a couple years, and this is our third one back in person. So we're excited to keep it all going. I'm sure you get our emails, but if not, you can sign up and get those for our next events. We're so excited to be here at Lacey, providing us this space. We just want to remind folks to wear your masks when you're not eating or drinking, just so we can create an accessible space for all of us. Um, just so everybody knows, this is a workspace. So Eric will be giving their presentation, and then we'll have about until like 10 a.m. to hang out, get to know each other a little bit more, and then we hit the road so people can get their work on for the day. So just so you know that. We're proud to be sponsored by Metro. So thanks, Metro, for sponsoring this event. We appreciate it. Just some news, if you want to take the Dash 8, it will drop you off right in front of Lacey. So if you're local, that might be a helpful way to take transit here. I'm so excited to introduce our speaker today. Please welcome Eric Dasmalchi. He is a research data analyst at Caltrans in the Division of Data and Digital Services. And today they're going to be talking a little bit about speed maps. So please welcome Eric.
Awesome. Thanks so much, Providenza, for that intro. And yeah, let's fix the bus in California. So in case you haven't heard of CalITP or the California Integrated Travel Project or the California Integrated Travel Program, um, it's a Caltrans initiative to kind of make transit work for people better across the state, really focusing from a rider experience point of view, whether that means things like enabling contactless payments, seamless benefits, transit discounts across the state in a centralized way, and also just making sure that transit travelers have the information they need to know that the bus exists, and hopefully beyond know that the bus exists, know when the bus is coming, have those real-time updates, and be able to go where you need to go. So this slide just has a few of those objectives. And so, there's kind of a lot of kind of different pieces that fit together to achieve those broader goals. And what I work on is sort of downstream of kind of providing all that transit data. Obviously, the main purpose of providing transit data is for the transit rider, right? Like, making sure every agency provides data in this GTFS, or the General Transit Feed Specification, the industry standard for communicating static bus schedules, routes, and then as extended by GTFS real time, which kind of provides those updates that says, the bus is actually here, or, it's supposed to come at 10:30, but it will come at 10:32, we promise. And that's mostly for the rider, to kind of build that confidence and be able to discover transit service. But as a side effect, we also collect it all at Caltrans now. So we have this kind of big, data warehouse and all this kind of amazing work that's been done over the last few years to archive kind of both those static GTFS schedule feeds and also archive those GTFS real-time feeds. So it's, every single position of every single bus and transit vehicle across the state every 20 seconds. We're collecting, it's a lot of data, and my job and the job of some others on our team is to make something useful out of it and figure out how we can use that analysis to support policymaking, to support advocacy, even, and then take it within Caltrans to especially if it's on our state highway system and we can see the buses getting stuck in traffic, like be able to support those processes to make it better. So yeah, on this slide I just have an image of my local bus. Of course, that's Transit app, which, back to today's intro question, is my preferred transit mapping and navigation app. Big fan of Transit. So you can see, from the rider, this is the data that says, oh, the bus is going to be here in 4 minutes. And then from us, we kind of collect it all and do these analytics downstream. In case you're interested in the tech stack of kind of the broader CalITP data warehouse, this is the kind of data infrastructure that I don't work on directly. That's some of the stuff we use. If you're really curious, you could find all the details on GitHub. Great part about our work is that generally it is all open source, so it's available. And yeah, just go into a little bit more, what GTFS real-time is and into the specification. There's 3 major components. There's trip updates in GTFS real-time, which is sort of like a kind of like a text-based or an information-based update that says like, oh, if you were trying to ride this particular trip, actually it's going to arrive 3 minutes later. And that's slightly different than, vehicle positions, which is just kind of a, latitude and longitude of a bus, of a train, of a transit vehicle. And, it, well, should at least have information that will let you link to kind of what trip that vehicle is serving. So you'll have, what trip this is supposed to be and where the bus is. So they kind of get at the same things, but it's two different data. And that's kind of why, if you've ever noticed in your transit mapping app of choice that, maybe you have a real-time countdown, but you don't see where the bus is, or perhaps vice versa, you see where the bus is, but you don't see a countdown. Those things are actually separate in the data feed. So when we build, at least for this project, our California Transit speed maps, we really focus on that vehicle positions data, and then kind of have our own logic to tie that back to the archived schedule, so we can know, which route, which trip that vehicle is serving. So why do we care about bus speeds? We have a bit of a transit problem in California. We've had, in some regions, certainly in the Los Angeles area, kind of a tremendous amount of investment going into transit over the last several years, especially new capital projects. And yet, even before the COVID-19 pandemic, transit ridership had, generally been declining throughout the state. And, there's definitely many reasons for that, lots of ways we can do better. But we think bus speeds are definitely relevant to that too. Speeds have been generally declining statewide, which is a problem, not only for the rider experience, because no one likes to sit on a bus stuck in traffic, but actually from an operations and service provision point of view, it's, really problematic for the transit operators. So, some of you may have experience with that, but basically, a bus sitting in traffic, can't get to the end of the route to become the next trip quite as soon as it could. So you can have a case where, agencies are maybe putting, the same number of service hours out there, kind of, deploying the same amount of labor, and yet it's, fewer trips and less service from a rider experience point of view on the transit network. So, we really think of this project as kind of daylighting some of those issues and, hopefully helping, various actors, whether that's other parts of Caltrans or local agencies that control local streets, kind of understand, where perhaps transit is experiencing the most congestion and help them provide projects that will fix that. Yeah, I've been working on this for a little while, I think about a year and a half now. And it was really fun because, we got to kind of iterate on it. So, the initial ask was, hey, we're collecting all this GTFS real-time data. What can we do with it? And that was kind of it. Um, so, so it was really fun to kind of just play around with that and figure out, well, what are we going to focus on? Should we have a dashboard of like, which trip IDs were served where and how that matched up? And we have built stuff like that. Should we try and, decide like which trips are like quote unquote late and, create a dashboard of like, these are the top 10 late routes. But what we kind of landed on, I think, because as a team with limited resources and trying to do something statewide in scale, we don't really want to be kind of the arbiters of, lateness or really kind of judging transit routes or transit agencies. But we can, fairly transparently present speeds. So we started working on speeds. We started, just, working with open source tools like Python and like Jupyter Notebooks, GeoPandas, the Python GIS library, and just kind of simple calculations to say like, well, can we at least get the speed for one route? So, I happen to have this example for a single route in Long Beach and just kind of put it on a color scale where, green is the bus going faster and red is the bus going slower. And so that works. And then it was kind of going on from there. It's like, well, can we have a whole transit agency at the same time? So that middle photo is a transit agency up in the Bay Area. Can we map multiple routes? There's kind of a challenge here, though, in just when you map transit routes. You might have seen, what we landed on is a little different than the way, like, say, Swiftly does it for their speed map projects that some transit agencies have access to, which is great. But, generally, bus routes serve both directions, right? And yet that kind of spatial data in GTFS for kind of where the route is, tends to be kind of along the center line of the street, or at the very least, when you kind of buffer it up to something that, you would look at a wider scale, looks like the center line of the street. So you kind of get a clash if you, try and show both directions of the route at the same time. And, there's various ways to get around that. You can have like a very interactive interface where you select just the routes you're interested in, just the directions you're interested in. But for us, kind of working with these more static tools, we were trying to figure out a way to sort of like disambiguate that and be able to see multiple directions at the same time. And we kind of landed on this approach where we'd just kind of offset the polygons slightly to the right of the street and do some kind of fun, like very low level spatial manipulation to turn them into little arrows. So in this slide on the right, that kind of, the top is kind of what we start with, like just that kind of basic buffered segment from one transit stop to the next. And then we just kind of wrote this little code that kind of creates these little clipping masks at the front and at the back, respecting the corner, obviously. And so you can think of it as kind of like a cookie cutter. So we have like a little arrow-shaped cookie cutter that we cut into our transit cookie. And now we have an arrow that you can follow on the speed map and tell which route goes where. In terms of making it available, we just kind of published it the same way we published a lot of our other analyses. So we're kind of doing a lot of development, a lot of iteration in Python, in Jupyter Notebooks. And our website is actually just kind of published from there. So you can kind of go from those Jupyter Notebooks, use tools like Papermill and JupyterBook to kind of turn what was kind of an interactive analysis notebook into a static website with a bunch of pages. In our case, we have it parameterized, and we just iterate through transit operators. So we build kind of one little page in our portfolio website for each transit operator with several speed maps, and we organize that by Caltrans district. Yeah, go from there. So we had that for a while, and yeah, it was really great to deploy those early speed maps. I'll actually go back a slide just to talk a little bit about the feedback we got, because at this stage, we finally had something that we could show transit agencies, show our partners throughout the state. And we got some interesting feedback, definitely. Like, I think I mentioned earlier, the kind of difficulties on kind of focusing on delay and lateness rather than speeds. And that kind of came from some early feedback we got from transit agencies where, in addition to the speed maps, we used to have a little table with like the 5 most delayed routes in your transit system. And we had these conversations with transit agencies, and they said, well, wait a second, that's not how we measure delay. Like kind of how can you possibly, as Caltrans, come in, at the statewide level and tell us this route is late? Like, is the data even good? And, we actually use a different definition, and there's a good reason for that, because you see it has to serve such and so high school. And we really heard all that. And so rather than sort of push back and say, no, we are measuring lateness at Caltrans today and judging everyone, we just got rid of it. We decided that the primary purpose of this tool is to provide maps of transit speeds throughout the state, because some agencies have access to really detailed tools like Swiftly, but some of them don't. So we're kind of setting the floor, setting the kind of baseline for, as long as you produce GTFS and GTFS real-time data, you can at least expect this grade of analysis product from Caltrans. And the second kind of feedback we got from transit agencies was really around focusing on speeds itself. So I'll show an example a little later in San Francisco. But basically the question was, well, in kind of in some areas, like, maybe it's not appropriate for the bus to go, 15, 20 miles an hour. We have a lot of pedestrians, we have a lot of smaller blocks. So it's not really helpful to us to have a map that just says, hey, the bus is slow everywhere. And what we're really interested in when we run our service is that kind of variation in speeds. Like, is travel time inconsistent? Is there one intersection where, sometimes the bus sits through 3 light cycles and sometimes it gets through? Because, that'll kind of play havoc with the way you plan service as well, and certainly also hurt the rider experience. So we kind of went on to develop maps of speed variation in addition to just speeds. We also had some challenges with the site itself. We've never really published a statewide transit speed map where it's one map with every single speed in the state, because we kind of knew that wouldn't work. But even looking at a single agency, LA Metro, right, is the largest transit agency in the state. Runs kind of the most buses over this huge geographic area. And on an original version of the speed map site, if you clicked on LA Metro, you had to wait, I think, a good minute or two in most circumstances, and sometimes it wouldn't really load at all. And that was because, it's kind of great to be able to iterate rapidly with Jupyter Notebooks. But when we rendered those maps in the notebook, the kind of static website just took those maps as is. And sorry, don't quite know the full story, but basically every map for LA Metro we put on would increase the kind of page size by like 30 or 40 megabytes, I think. So it was this question of like, we'd love to present, more information, speed variation. We'd love to, be able to compare like morning peak to midday to afternoon peak. But in the initial approach, or the more content we put on, the kind of more unworkable the website became. So it was also a little hard to deploy on our end, but that was kind of secondary. The other question is, it's great that we can show our little maps, but ultimately we want to make this available as open data, right? And be able to work in, be able to kind of provide this data source to support other people's, mapping workflows or what have you. And there wasn't kind of a clear way to do that from the initial site. So we worked with our data services consultants to make, a few improvements. Another one of them was this state highway system layer. So some of the conversations we had in Caltrans were kind of around this theme of, we own, operate, and maintain a lot of state highway. transit runs on some of it, not necessarily a lot of it. Most of the places transit runs are local streets, but there's, some places that are certainly our problem as Caltrans, where transit is getting stuck in congestion. So we were kind of asking, our local Caltrans districts throughout the state to do these planning exercises on, where we can speed up the bus on our system. And I got this, feedback from a transportation planner that said, like, these maps are great, but if we're trying to figure out, where the state highway system is and where that interaction is, they don't really let us do that. And before I was kind of apprehensive about cramming one more layer into the old maps, but kind of as part of that kind of refactor for performance, we were able to add this kind of cool background layer. So now our state highway system is outlined in gray. One thing I kind of went back and forth with my supervisor on is, is it really time for a new tech choice? Because, on the one hand, it would be great to have this additional capability for speed maps, but there's also this, kind of very real and well-justified perspective that, especially for a smaller team that, maybe doesn't have the resources to maintain, 15 different data pipelines that work in 15 different ways and kind of publish, a bunch of different websites, that we don't want to, sprawl out too much. So we really need to kind of justify when we're changing things. So one option would be, move towards some sort of website that's more interactive. Maybe there's like actually a server backing it. But that, that would have been a lot of work and kind of created something to maintain in the long run. So I won't go through all of this, but what we kind of landed on is, well, if the problem is that, just kind of the basic maps from the Jupyter Notebook take up a lot of data and are hard to load, maybe we can make just the maps better. So our data services consultants were able to figure out kind of a very simple web application that would just take a zipped GeoJSON file from our existing Google Cloud Storage bucket, render it into a much more performant map, and then rather than kind of create a new website or create a new branding for speed maps, it would just kind of embed in the existing Jupyter book site and the existing portfolio. So the look and feel of kind of where the site was and how you navigate it was largely the same, and we just ended up with better maps that don't take ages to load, have a little more interactivity, and also let you download the data, at least individually. Skip over this for now, but if you want to look later, we've had kind of various efforts to document what's actually going on in all the code we've put together. Yeah, and so I think finally I'm going to take through a couple examples. Great. So we're going to start in right here in Caltrans District 7 with our LA Metro speed map. Great. Yeah, so by default, our maps show 20th percentile speeds from a transit stop to the next stop for each map, each route. So this is kind of the central portion of the LA Metro system in the morning peak, and generally have these maps available for morning, midday, and afternoon. And yeah, and if you mouse over it, you can get kind of a little additional information. So I'll go from here. We can go to another part of the state. Let's head to District 4, San Francisco. So give me a moment. Yeah, so this is one example where, if you look at the maps, the bus speeds are kind of low, but maybe that's not the full story. Like, maybe it's, or in fact, it's, definitely important to provide data beyond just speeds to, best support our partners. And so in the newer version of the site, we provide this speed variation map where we're no longer mapping just kind of those aggregated speeds from segment to segment. Rather, the segments in darker blue kind of have the most variation where, some trips get through quickly and some trips get through slowly. So that's kind of another way to prioritize, where we can best put transit priority in the state. And finally, I'll show one more. Let's go to District 5, Santa Barbara. Cool. And so here's what a speed map looks like for, perhaps a smaller city operator. We are very proud that, kind of thanks to a lot of the amazing work that others on the team have done in just supporting our 200 plus transit agencies across California in providing their data, in open data standards like GTFS and GTFS real time. We do have a speed map for at least one agency in every Caltrans district, including, up in Eureka. So this is really, it's not just a project for Los Angeles. It's not just a project for San Francisco. We really want this to be something available statewide, and we're going to keep working on that. Great. Go back to the presentation for just a moment. But some of the things we're working on next is, we really want to make this available as open data. And right now it kind of is. You can navigate the speed map site. And if you're looking at a particular map, you can download the data for that map. But really, this should be on the state open data portal. You should be able to download a data set that's like transit speeds, California. And for various reasons, we're not quite there yet, but hopefully very soon we'll kind of have, kind of more efficient processing infrastructure and kind of, ways to kind of tag particular segments, not just as belonging to this one transit operator, but understanding, what about all the transit routes in this kind of particular stretch of roadway, or be able to do kind of more robust analysis through time and really understand those trends. Whereas right now we kind of have a sampling approach where we try and pick one representative day per month, and that's what we build our speed maps on. With that, I'll end it here. So thanks so much for listening, and happy to take any questions.